Okay, so I'm back with part E. We're going to work on finding the absolute maximum in this problem. If you'll remember, to find an absolute max, I create a table of values, starting with my endpoints and listing any internal candidates right in the middle. For this problem, your internal candidates need to be your relevant roots. I have two roots according to this graph, but the only one that's relevant is over here at +2, since that's where our relative maximum occurred. -2, there was no max or min, so I'm not going to include that in my table. So from here, I just need to identify the values of the function at these three places. So I've got g of -6, g of 2, and g of 3, which need to be computed. Luckily, I found g of -6 in part A, it was -10, and I found g of 3 in part A, which was 2 pi minus 1. So the only real work for me to do here is to compute the value of g of 2. That's the integral from -2 to 2 of f of t. When I look at my graph, that's just this semicircle right here. Area is half of pi r squared, so I'm getting an answer of 2 pi. Once that work's done, I can scan my answers and look for the biggest output, which, after careful consideration, is definitely at 2 pi. So my absolute max equals 2 pi. Nothing else needs to happen here. That problem's done. All right, guys, so for this last question, we're asked to find the horizontal tangent lines of h of x. Let me flip here real quick. There we go. And h of x is defined for us as the integral from -2 to x of f minus 5x. Very similar to a question that we saw on the other page, but this time it's h that I want the horizontal tangent lines of. That means h prime needs to equal 0. That's where horizontal tangent lines exist. So h prime, let me figure out what that is. That means I need to find the derivative of the integral. That looks familiar. That's just f of x minus the derivative of 5x. That's 5. Think about this, guys. This is a graph of f. This minus 5 right here is telling me to take this graph and shift it down 5 units. If I can perform that transformation, I will be looking at h prime after I've transformed the graph of f, and I can find when it equals 0. Notice, the maximum at the top is 5 units up, so if I shift that down, I'm now sitting on the root, and my graph looks something like this. The only root here occurs at x equals -4, and it is not a max or a min because there's no change in sign. Study that. I promise it's going to be on your test tomorrow. Good luck. I'll see you later.